First, download the part file top cover. Then open it from Annex using the open command. You always want to open it from this inside the session. Then save it as and also put your initial. You're going to use your own initial in the correct folder. Now we're ready to start our lab activity number 6. First, we're going to create expressions to describe the dimension of this model. First, we're going to create the length 100 millimeter. Make sure you have a number with the type, dimension is the length, and the unit will be millimeter. Hit enter. Apply. Then this expression is created and being saved in this file. Then the height, let's say 5 millimeter. Width 80 millimeter. Rim 3 millimeter. Rim D 3 millimeter. Rib thickness 0.5 millimeter. Rib length. This time we give a formula. Length minus rim width times 2 and a minus rim D times 2. You can see this equals 88. Now we haven't hit apply yet. That means all of them is not saved yet. So once you hit apply, then all of them should be included in your file. However, at this point, you still have this modified. So the file have been modified, but is not saved on your disk yet. So pay attention to that. So if you want to save the changes or satisfied with the modifications, save it, then it will be updated on your disk, and the modification symbol is disappeared, and you can see user-defined expression have been listed here. Now we start to create a sketch. Go to Home tab, click Sketch. This time we're going to use XY plane as a sketch plane, and also use horizontal as a reference, and we would like to make sure X is our axis, horizontal axis. The specific point will be the origin. Okay, so let's find the point. You can see we would like to define the plane, which is XY plane. You can also put your cursor here and then XY plane, right? So x-axis, that is the horizontal reference. What we can choose, you can see, because we would like to choose this one, which is the x-axis of the coordinate system. X-axis as our specific vector, and then the point, we would like to choose the origin, which is existing origin of the datum. Hit OK. Now you can see specify C as coordinate system is being checked. Hit OK. Now you can see the sketch X, Y direction is same as global coordinate system X, Y direction. Now let's create a rectangle. Use the center form. We want to use sketch origin. The width will be equal to L, height equal to W, the angle will be 0. You can see. Okay. Now we're going to offset this one using offset curve. We're going to click make sure connected curve is selected. So when you select one curve, then the whole curve will be selected. We would like to create inner offset, so we would like to change its direction. Here we're going to use formula make this one equal to rim underscore width, which is 3. Hit OK. Now you can see. Then another inner rectangle, which is 3 mm away from this outer rectangle, is created. Alright. We're going to create one more rectangle, represents a rib. Again, still use this one, and we would like to choose the sketch origin again. Sketch origin. The width will be rib length, which is 88, and it will be rib thickness 0.5. Angle will be 0. When you hit enter, it gives you the result like this. Okay, once you're done, then we finish the sketch with the 3 rectangles. One's inner, represent the rib section. Another one is the outer rectangle. The largest one represents the base, and an inner rectangle which represents the steps. Now finish sketch, and when you click isometric view, you should be able to see orientation like this. Save your file, then we can go to next step. Now use extrude command. Select the rib. You can choose a single curve and include individual curves of the rib, or you can use a connected curve, and then select one of them. The whole rectangle is being selected. And now this formula, starting from 0, formula, scale 50. Hit OK. Preview. Okay. So use isometric view. See, check your result. Once you're satisfied, hit apply. Save your file. Now you have extrude. That's a rib. Now we're going to create the step. Again, use connected curve. Make sure you select the inner rectangle, and then we would like to, from 0 to rim D. Let's see the result. It's extrude upward. We would like to reverse vector, so it will go downwards. Check again. Yes. Once we're satisfied, hit OK. Now, if you use this rotate, you can see the step is correct. Use isometric view, you should see something like this. Save your file. Now we're going to use outer rectangle to create another extrude. Make sure you use none. Again, connected curves, and then reverse, so it will extrude downwards, and the distance starting from rem D. So it will start from the bottom of your previous extrusion. This one will be rem B, rem D plus H. It will be 8 millimeters. You can see. So once you're satisfied with the previewed results, hit OK. Make sure you don't put this United or anything here. Let me check this one. It's none as well. So what do you have? You should have 1, 2, 3 solid bodies. Let's check. So go to selection filter and check solid body. So 1 body, 2 body, 3 bodies. Save your file. Make sure you switch back to no selection filter. Now let's create one more datum coordinate system for later use. Use dynamic and the reference use WCS. Specify orientation. Let's select the point dialog box. In field, we would like to use the point on the face. Then the face will be the top face of this rib. Hit OK. Now, parameter, let's use 0.5. And the V parameter will be also 0.5. And then you can see it will be X, Y, Z absolute coordinate system will be 0, 0, 50. No offset. So you can see. Hit OK. And here you may have different value here. Scale factor, make sure scale factor it will be 3. So hit OK. Then you can see this datum coordinate system much bigger than the one at the bottom. Save the part. You can also see this coordinate system is located at the center of this surface. Use the pattern feature to create more ribs. Pattern feature. Let's select the rib and we use the default pattern origin. So specify point, the default AP. Now we're going to use direction. We're going to use Y direction and count and pitch. The count will be 10 and the pitch distance we're going to use formula here. Your is empty here, then we're going to type rib T times 10. in this case, we will make sure the distance between each rib is 10 times of its thickness. So we can the boundary by default is none, so you can see we also would like to make symmetry, so you can see 10 on each side. So from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we look at it from the front view, the right view, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Starting from here, 10 as well. So in total, it will be 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So in total it will be 19, right? So that's the result. However, you can see if we use the settings, then what's happening is the rib will go outside of the bottom, right? So what we can do here, we can add a boundary condition. So the boundary condition will be use face. We would like to use this top face as our boundary. Say face. Then you can see from the right view, and let's see the results. Preview. Okay. Right, so you can see we have ribs being distributed here. We can add more. We can add more here. So margin distance, we can make margin distance. That means at least the rib will away from the boundary, at least say give the rib T times 10. You can see, right, in this direction. And we also apply the margin to the internal boundaries if there's one. Now you can see the minimum boundary away from the minimum margin away from the boundary to the rib will be greater than the parameter greater than the 10 times of the rib thickness. Once we done, use isometric view to bring it to the normal direction, and then we can save our file. Now we're going to make another sketch. Use this one. So click sketch, specify coordinate system. We're going to use Z, Y plane of this datum coordinate system. YZ plane of datum coordinate system, and specify vector. We're going to use this direction, and then specify origin. I'm going to use origin of datum coordinate system. Hit OK. Then you will see X, Y in this direction. Hit OK. And hit OK. So when you see Z, Y coordinate system is in this orientation, then you're in the correct location. Now we're going to create the arc. Use this arc. We're going to use by 3 points. So the first point starting from negative 35.25 and Y negative 25. Hit enter. You see, then the first point is located here. Use this origin as a reference. So the radius we're going to use is 100 millimeter. Now you can see, right? Okay. So accept this. Then we're going to use we're going to define the endpoint. So endpoint we would like to use coordinate system, right? So it will be here, symmetrically above that direction. So what we can do here, it will be 35.25 and Y coordinate system will be negative 25. Okay. Once you have, then we accept by collect the wheel or bottom, center bottom. Okay, now you can see, right, from distance, the distance from here to here is 35.5. Okay, now finish. You can see we have a sketch in here. Save the file. Now we can check the sketch. Use the right view. You can see the sketch is displayed here. Okay. Switch back to isometric view. In the Path Navigator, we highlight the sketch and then use the drop-down menu here and use Revolve. Okay, so we're going to revolve this one. The vector, we're going to use, make sure the y-axis is your vector here. Okay, if you're using, if y-axis is not specified, you can choose this direction, or you can choose y direction directly. Specify point. Then use the point dialog box here, and then we're going to select the highlight the select object. Okay, highlight select object and click the curve to select the center point. Arc center. You can see here the center point of this arc is being selected. Okay, and then we would choose offset, use rectangular. Okay, then we would like to type delta Z, type 150. Click isometric view. You can see the point is moved down to here. Okay, so we're going to, in your case, maybe the value is like this. That's what you see. We would like to choose -20 to -20 and 20. Oh, -20. Okay, so preview. I think this covers all the ribs, so I'm going to hit apply or use the middle button to accept the parameter. Let's rotate. You can rotate using this one. So hit OK. Now we have the trimming tool. We're going to trim these bodies so we will be able to create the shape of the top. So trim body, target. The bodies we would like to choose are those ribs. You can choose from here by individual ribs, or you can select from the patent features and the rib, right? 13 ribs in total. Then select the face or the plane. So we would like to choose this. Okay, so if you need to reverse direction, then you can change direction. And then use the preview. You can see here's the results. I'm satisfied with my result, then I'm going to hit OK. Save my file. Go to isometric view. This is the shape. Then we want to make a single body, right? So we're going to hide everything else, but only the solid. So what we can do here, we can unite first. Unite. Unite. We're going to use any of this solid, and then all the bodies here. Hit OK. Now I should only have one solid. So solid body, you can see I only have one solid body. Let's save the file. And then we're going to hide everything else except this solid. So we're going to hide the datum, hide the sketch, hide the sketch, hide the sheet body, and also hide this one, this datum coordinate, coordinate system. You can see we only have the solid being displayed in the graphic window. This is the trim function we learned from here. So save the file.